Start? Yeah. Okay, so hello everyone. Myself Gaurav Mishra, and we are going to start, we are going to learn, the topic is called Indefinite Integration. Okay. If we start with the definition for the indefinite integration, so the very first concept that we learn about the indefinite integration, that is the indefinite integration is a reverse process of differentiation. But before going to that idea, the reverse process of differentiation, okay, if a function fx, okay, you can look at this here, the function fx, is called a primitive, or it is called an antiderivative of a function fx if the derivative of f dash x is equal to small fx. Okay, so this is the idea of primitive basically. Okay, if the derivative of a function is equal to some other function, the capital Fx is called the derivative primitive of small fx. Okay, so with the help of this primitive, we start the introduction of indefinite integration. So what you can look at the introduction of indefinite integration. So what you can look at it here. From this term or this? Upar se. Okay. Yeah. So, yeah. So, if we look at these functions, x to the power 6 upon 6, x to the power 6 upon plus 1, x to the power 6 upon 6 minus 1, we can see all these three functions will give the same derivative x to the power 5. Okay, that means all three are primitive for this function x to the power 5. Okay, so what we can see, if we add a particular constant to the function, okay, we can add any constant to the function and the primitive remains same. Okay, so what we can see, if there is a function fx and it is connected with a constant c, then we say fx plus c is also a primitive for fx if I differentiate this function. Okay. So with this idea of a primitive and a constant and the function, we can see the proper definition of integration. It's not changing. It's not changing. Yeah, so that is a definition for the integration. Yeah, so if we talk about the definition of the function integration, is say fx is my function. So fx is my function, then the collection of all its primitive. So all primitives can be collected in this form, fx plus c. Okay. So if the collection of all its primitive, this is called indefinite integral. This primitive is called indefinite integral of fx. And the notation that we use to define this integration is that we integrate fx with respect to dx, or with respect to x we call it is. So when we integrate this function fx, we'll got all possible combination of primitives. So that we'll got fx plus c. So this is how we define that the differentiation of fx plus c will give us fx. So these are the collection of all possible primitive. So when we integrate this function fx, we'll get the all possible primitives for this function, and this is we called fx plus c is an integration of fx, and here the fx is called integrand. It is called integrand, while capital Fx is called integration. C is called integrating constant. So these are the symbols that we use in the integration. My fx is integrand, this is my integrand we have, this is the integration of function, and this is the integrating constant that we need to add to get the all possibility or to get the all possible collection of the primitives. So this is how we define the integrations. Okay. Now if we look at the basic formulas for the integration, okay, so before going to the basic formulas of integration, let's try to understand the differentiation between the integration and differentiation. Yeah, again it is stuck. Yeah, okay, so when we look at the basic comparison between the differentiation and integration, how we can differentiate, how the differentiation is different from the integration. The first difference is differentiation and integration both are operations, or we can call them operators. Both are the operators that apply on functions and which gives a different function after the operation. So what we call them, differentiation and integration, both are the operation which gives a certain rise to a function. Okay. Second difference is each function is not differentiable or integration. As we know, in the differentiation, every function can't be differentiated. A similar type of rule is attached with the integration, that every function can't be integrate. Now if we look at another difference between the integration and differentiation, the derivative of a function, if it exists, it is unique, but the integration of a function, if it exists, it may or may not be unique because of the plus c, that idea, the idea of constant that we are adding with the function, that constant which gives us the situation that the integration of a function is not unique, but the differentiation of the function is always unique. The derivative of a polynomial function. Okay, so that is a general understanding about the differentiation and integration. In case of the differentiation, if we try to differentiate an algebraic function of the form x to the power n, the power on that function get decreased. Okay, while in case of the integration, the same functions will give you increasing sequence of powers. Okay, so that is another difference. The polynomial function, in case of the differentiation, the degree will be reduced by 1 at each step of differentiation, while in case of the integration, at every level the degree of term or the degree of polynomial will be increased by 1. Another difference is the derivative has a geometrical meaning, and that is somehow connected with the slope or the tangent of the function. Okay, this is how we define the interpretations, or you can say the geometrical meaning of the differentiation. That differentiation is a slope, or it is a type of tangent, or sometimes we call it as a rate of change of a variable with respect to other variable. That is basically the geometrical or physical interpretations of the derivative. Okay, now if we talk about the interpretation of the integration is somehow connected with the area of a region, a closed boundary. Okay, that is we start learning when we finish the indefinite integration and will start the definite integration. Okay, the purpose to learn the integration or indefinite integration just to learn how to do the definite integrations. Okay, and definite integration has the application to find the area of closed region. Okay, so that is a application or the physical application of the integration. That integration is used to find some sort of regions, some sort of volume, some sort of length of the curve. Now if we talk about another difference between the differentiation and integration, the derivative is used in obtaining some physical quantities that we use as an application for the derivative, and that is, it is used to find velocity, it is used to find acceleration. It is almost everywhere, the derivative is almost everywhere where we are just measuring the one variable, or we are measuring the change in one variable with respect to the change in other variable. Okay, while in integration it is used in some physical quantities, like we need to find the center of mass of the body, or we need to find the momentum in the body, and there are some other applications. Say for example, I need to find the area, or we need to find the volume of a particular solid figure. So that they are the particular situation where we can use the integration. Differentiation and integration are inverse of each other. That is the most famous or the most commonly known property about the differentiation and integration, that they are inverse to each other. That means whatever function we are receiving after the differentiation, if we do the integration of that function, we will receive back to the original function that will describe in the coming time. Okay. So this is how we can differentiate differentiation and integration. Now if we talk about the basic properties of integration before going into the examples or the problems how to get the integration of a function, we need to understand few basic properties of integration. And the basic properties of the integration are, if I need to integrate a function fx, okay, and this function is multiplied by a constant c. So in this case, the c can be taken out to the integration sign and rest function can be integrate with respect to x. Okay, so in this case the dx we are writing here, this is the variable. In this regard we are doing the integration. So we are integrating this fx with respect to the variable x. Okay, and this is the sign of integration we have. The symbol that we are drawing here, it is the sign of integration. Okay, so whenever we need to integrate a function constant into the function, we can take out the constant. From the integration sign. That means constant is independent from the integration. Constant is independent from the integration. Now if we talk about the sum of two functions or the product of two functions, there is a special rule we have for the sum of two functions, while the product of two functions is a different type of calculation that we known as a by-part integration in case of the indefinite integration. But for the basic sum and difference of the two functions, if we have a sum or difference of two functions f1 and f2x and we need to integrate it, that integration can be solved by the integration of first function, the same plus and minus sign, and the function and the integration of second function. So this is the simple addition or subtraction rule, okay, on integration. So this rule can be extended. We can have a generalized rule. Okay, the generalized rule is the integration of c1 into f1x plus minus c2 into f2x plus minus so on up to cn into fxn. I need to integrate this entire function with respect to x. So what I can do, I can break this integration into the sum of a small integration. So in that case, the constant is out for the first function and we can integrate the function, then plus minus the c is out for the second function and we can integrate f2 with respect to x, and similarly we can do for the last function, constant is out from inside to outside and I need to integrate f and x, and now if we can add them, I can get the integration of this left side. So rather than to get the integration of say 5 or 6 added function, what we can find the integration of each term separately and later on we can add them to get the original integration whatever is asked. Now if we talk about the basic formulas that we use in the integration, okay, the basic formulas in the integration started from the integration of 1. Okay, so for the integration of 1 we have to integrate 1 with respect to x, and the integration of 1 with respect to x, it is called the integration of nothing. That means 1 can be visible here and the integration of 1 dx is c. This is the very first basic formula that we have in the integration. Now if we want to just learn how we are getting this answer basically, okay, so what we can do, since the differentiation of a constant is 0, the differentiation differentiation of a constant is 0 in case of the derivative. So if we need to integrate something, okay, my answer should be c. Okay, so integration of constant is 0. So if I have to integrate say nothing, I'll got c here. Just a sec. So now look at this integration of 1. Sorry, not integration of 1. I need to find the derivative of 1. Oh sorry, derivative of x. So derivative of x we got 1. So if I integrate this 1, I will get back my x back. This is the idea that we use in case of the differentiation. Just recall it again. If I differentiate x with respect to x, my answer will be 1. Or if we integrate this 1 from here, if I integrate 1, I will get back to my function x. This is how the differentiation and integration are connected. That's why we call the differentiation and integration are inverse to each other. Okay. Now that idea of plus c is also there. That means if I differentiate x, the result may be 1, but if I integrate say for example, if I am differentiating say x plus 5, I will still get 1. If I differentiate say x minus 1, I still get 1. Okay. So in that means if we integrate this 1, that means if we integrate 1 with respect to x, I may get x and any constant with it. So that is how we get the formula. The integration of nothing is x plus c. And by this formula, we can have a general formula, the integration of a constant with respect to x. So this constant can be taken out as per the property of indefinite integration, and I have to integrate nothing inside it. So the answer will be kx plus c. So this is how we use the formula. This is how this formula will be in use. Okay. Now the second formula for the integration of x to the power n dx, and this formula is x to the power n plus 1 upon n plus 1 and integrating constant in the end. Okay. So you can look at this situation. If we differentiate this x to the power n plus 1 upon n plus 1 n plus c, I'll get my answer x to the power n. That you can verify your own. If we differentiate this function, I'll get my x to the power n back. Okay. So this is how we get this integration formula. That means if I integrate this function, I'll get back this function as my primitive. Okay. So this is the integration of x to the power n dx is x to the power n plus 1 upon n plus 1 plus c. Okay. Integrating constant we need to add every time. Now more general formula for x to the power n, if we have this ax plus b to the power n dx. Okay. The formula will be 1 upon ax plus b to the power n plus 1 upon n plus 1. This is missing here. Okay. Okay, this is n plus 1. So that is the formula we have for ax plus b to the power n dx is 1 upon a into ax plus b to the power n plus 1 upon n plus 1 plus c. Okay, this is the most, you can say the general form for this x to the power n, and this formula can be explained with the rule is called substitution rule in the indefinite integration that we are going to take later on. Okay. So that we will see how we get this formula of ax plus b to the power n dx in this particular form. Okay. A similar formula, another formula, okay, for the 1 upon x dx. It's a special formula. In case of the integration, we never integrate x to the power minus 1 dx. We need to write this integration as 1 upon x, and that answer we got is log x. So what we have, because the derivative of log x is 1 upon x. So that's why the integration of 1 upon x is log x plus c. Another formula, the general form for this is 1 upon ax plus b. This answer will be 1 upon a log of ax plus b plus c. Okay. So that is a general form. Again, this formula can be explained with the help of substitution rule, or this result we can find with the help of substitution rule. Another formula that we use most prominently in the indefinite integration, that is integration of e to the power x dx equal e to the power x plus c. So this is the function which never changed during the integration as well as differentiation. If we recall ourselves to the differentiation of e to the power x remains e to the power x, and the same property we have in integration, that the integration of e to the power x will be the e to the power x, and we need to add an integrating constant to get all the collection of primitives. Okay. Now a general form for this formula, if it is a special number we have in e to the power x, and what we call it is, we call them as Euler number. This e stands for Euler number. Now but we have any number in this exponent. Okay, so this is my base for the exponent a to the power x. So in such case the formula will be a to the power x upon log a plus c. Okay, so that we can see the differentiation of a to the power x. Okay, that was a to the power x and log a. Okay, so that's why we got the derivative of this function as a to the power x upon log a plus c. Okay, so these are some basic formulas that we need to use. Again, the differentiation of sin x is cos x, so the integration of cos x is sin x. It's a simple rule. Okay, the idea of inverse between the differentiation and integration. Differentiation and integration are reverse process to each other. So what we have, sin x and cos x, when we integrate cos x we will get sin x, when we differentiate sin x we will got cos x. Similarly, you can look at the situation, this is based on the derivative of cos x. So derivative of cos x is minus sin x. The derivative of cos x is minus sin x. So that's why the integration of the sign we are receiving is minus cos. So that is a one point that we need to learn in this case. In case of the differentiation, the sign become positive cos, but in case of the integration, the derivative of sign become negative cos x. While in case of the differentiation, the derivative of cos x was negative sin x, while in case of the integration, the integration of cos x become positive sin x. That is a one point that we need to learn, that we need to memorize. So that happens with the differentiation and integration. Now another differentiation that we use, differentiation of 10x. The differentiation of 10x was sec square x. So if I integrate this x square x, I will get my 10x back. Okay, so we get a formula, this result become a formula that the integration of sec square x is 10x plus c. Okay, so on the same sequence, the integration of cosec square x is minus cot x plus c. Okay, yeah. So integration of cosec square x dx is minus cot x plus c, because the differentiation of minus cot x will be cosec square x. Okay, so that's why we get this formula. Similarly, the differentiation of sec x was sec x tan x, so the integration of sec x tan x is sec x dx. The derivative of cosec x was minus cosec x cot x, so the integration of cosec x cot x will be minus cosec x plus c. And similarly, in case of the inverse trigonometric functions, the derivative of sin inverse x was 1 upon square root of 1 minus x square. So we have the formula that the integration of this 1 upon square root of 1 minus x square dx become sin inverse x, and the differentiation of cos inverse x, it was 1 upon square root of 1 minus x square. Okay, and we get a minus sign here. Okay, so that was the derivative of cos inverse x. So the integration of this 1 upon square root of 1 minus x square dx is either minus cos inverse x or it is sin inverse x. And another formula for the inverse trigonometric function was for the derivative of tan inverse x, it was 1 upon 1 plus x square. Okay, so when we do the integration of this function, 1 upon 1 plus x square, we will get the tan inverse back. And similarly, we have the formula for cot inverse x. So d over dx cot inverse x is minus minus 1 upon 1 plus x square. So if we integrate this 1 upon 1 plus x square, we have the two choice. One is the positive tan inverse x and second is minus cot inverse x. So you can see the integration of this function is not unique. If I need tan inverse x in some cases, I will go with this formula, or if I need minus cot inverse x, I will go with this formula to get the integration. Yeah. Now look at some problems, how we do the calculations in the integration. Okay, so I have just picked some basic examples to start the indefinite integration. So I have to integrate this ax cube plus bx square plus c divided by x to the power 4 dx. So this is the function, this is my integrand here, this function is called integrand. So I have to integrate this ax cube plus bx square plus c over x to the power 4 with respect to x. So what simple thing I can do, I can use an idea of partial fraction basically, or we use the concept of fractions. I can take this x4 below to the every function, I can take this ax cube upon x4, then I can do bx square upon x4 plus c upon x to the power 4 and dx. So they have just break the term into three different terms. Now if we do some simplifications, we will got a upon x plus b upon x square plus c upon x to the power 4 dx. Now we can do some more adjustment in it. A upon x plus b x to the power minus 2 plus c x to the power minus 4 dx. Okay. So what is the answer now? As per the formula, the integration of 1 upon x is log x. So the integration of first function is a log of x. That is the integration of 1 upon x. If we integrate the second term for x to the power minus 2, it will be minus 2 plus 1 divided by minus 2 plus 1, and third function minus 2 plus 1, and my third function is c into x to the power minus 4 plus 1 upon minus 4 plus 1. Okay, and I need to add one integrating constant. Okay, so I am adding the k here. Now I have to just simplify all the terms. I have already integrated the function. So I am going to adjust this. Minus 2 plus 1 will be minus 1. So we have a minus b and x to the power 1 only. While the last term minus 4 plus 1, we have minus 3. So minus c upon 3 x to the power 3 and integrating constant. So this is how we do the integration. A simple polynomial functions we have in numerator and denominator as well. So what we did here, we have just separated all three terms, dividing by x to the power 4, simplified them, used the formula, and we need to summarize the results. Okay, so this is how we do the simple integrations. Okay, now if we think with the new problem, if I need to evaluate this integration of 1 plus x plus square root of x plus x square upon square root of x plus square root of 1 plus x. Okay, so we need to think little widely and what we can do to simplify this function. Okay, so for the simplification, what will go, I'll put the 1 plus x in one bracket, the first two terms, and I'll take something common from these two terms, and that common can be taken out is square root of x, and we received remaining terms inside the square root is 1 plus x. It is divided by square root of x plus square root of 1 plus x and dx. Now what we can do in numerator, we can take 1 square root of 1 plus x as common, okay, and inside the bracket what we receive square root of 1 plus x, and in the second term we receive only square root of x. This is common basically from here. This is just taken out from both the terms, and it is divided by root x, this plus 1 plus x. Now the two terms, these terms can be cancelled out. These two terms can be cancelled out, and what we remains? We remains with the integration of square root of 1 plus x dx. The square root sign can be written as it is the integration 1 plus x to the power half. We can convert the square root sign in powers, and now we can apply the formula, and as per the formula this integration will be 1 plus x to the power 1 by 2 plus 1 upon 1 by 2 plus 1, and I need to add one integrating constant. Okay, so when we simplify everything, we receive 2 upon 3 1 plus x to the power 3 upon 2 plus c. So this is how we end up this problem. That is the integration we have received. So by using some simple arithmetic, what we did here, we have just simplified the integrand in a simpler form, and now we can apply a direct formula on it. Okay, so this is how we can proceed for the situation. Now if we talk about this example, another problem we are taking, okay, the integration of dx divided by 2 square root of x 1 plus x. Just a sec guys, yeah, before going to that problem we need to understand the situation. The situation is that we call the integration by substitution. Sometimes it's not easy to integrate a function which is whatever the form is provided. So what we do, we use certain types of substitution. In different situations we have different types of substitution that we can do. So we have a different formations. As per that form we use the substitution method. So very first form we are taking is when the integrand is a function in this particular form, where f is a function of phi x, okay, f is a function of phi x, and this function is multiplied with its derivative here. So in such case we'll assume let phi x is t, and we will differentiate it. We will receive phi dash x dx equal dt. This is how we differentiate phi x equal to t. So by using this substitution, these two substitution, my function which is given here, it can be converted as a function of t, that we have just assumed phi x as t, and this phi dash x dx, it become my dt. So this is a simpler formation of the integration which we can try for the integration. So this is the one idea of substitution we have. So we need to choose a function wisely, which function I should choose as a t. Okay, so before going to that t, look at the formation of integrand. Okay, what will be the suitable, so that will came to know as per the experience. Whenever you try a problem, you will get to know that which function I should assume as my t. Another situation is when integrand is the product of two factors. and the factor is like that, one factor is a derivative of other. Okay. So what we have a situation, there is a product of two function, but they are derivative of each other. Basically we have a fx or fx, the derivative of fx is multiplied here. Okay. So in this case also what will assume? Will assume my fx as t, and when I assume my fx equal to t, the differentiation will give us f dash x dx will be dt, and when I use this substitution, here, what I receive? I receive integration of this f dash x and dx. These two terms combinedly will convert into dt, while this fx is assumed as t. So I need to integrate this t dt, and the integration of t dt will be t square upon 2 plus c, and finally I can find my t is fx, that was t. So we have that is as a final answer, f of x whole square upon 2. So these are some methods that we use for the substitution. There are several methods. We can opt for the substitution. Different types of substitutions are there that we can use. Okay. So let's proceed for the problems based on the substitutions method. Yeah. So evaluate the integration of dx over 2 square root of x 1 plus x. So what I'll do, I'll assume let root x equal t, that is x to the power half we are assuming as t. So from here 1 by 2 x to the power minus half dx will be dt. Okay. So we have 1 upon square root of x dx equal 2 dt. So these are the two substitutions we are going to use, one substitution and two substitutions basically. Okay. So my integration given is my dx with this root sign, that will convert into 2 dt. A 2 is already there in denominator, that will keep as it is, and remaining term 1 plus x, the x can be written as t square from this substitution basically. Root x equal to t, my x can be written as t square. This 2 can be cancelled out, and I have the integration of 1 plus t square, and for the 1 plus t square I have a direct formula with us, and that formula is tan inverse t, an integrating constant. Later on I can replace my t in terms of x. So what I have substituted here, I have just substituted this root x as t. So this is how we get this integration. Okay. So I have to choose my function to substitute as t. Now if we look at this another example for the substitution, I'll choose I'll choose let tan inverse x cube equal t. So we'll go for this substitution, tan inverse x cube equal to t, and from here I got 1 upon 1 plus x cube whole square, that is a formula for the integration or differentiation of tan inverse x, 1 upon 1 plus x square, and with the help of chain rule we got 3x square here and dx equal dt. So from here what I receive, I have just received that x square upon 1 plus x to the power 6 dx equal 1 upon 3 dt. So that substitution will use here, integration of this tan x tan inverse x cube, this is t. The remaining x square and 1 plus x to the power 6, this with dx will convert into 1 upon 3 dt. 1 upon 3 can be taken out. I need to integrate only t in this case, and the integration of t is t square by 2 and integrating constant, and later on I can write t as tan inverse cube. So, t is tan inverse x cube whole square and integrating constant. So, this is how we proceed for the substitution method, the different methods that we can try. Some other forms of the substitution method, if the function is of this form, function of ax plus b, okay. So, in such cases what we assume, let ax plus b equal to t. Use the substitution and convert your integration into a simpler form and just proceed with the normal rules. Another form where the derivative of the function is divided by the function, or you can say the derivative of function is available in denominator while the function numerator, while the function is available in denominator, we can use a direct formula, the log of fx. So, in this case also what we assume? We assume this fx as t, a substitution we are using, then you will reach to this answer, log of fx plus c. So, these are some methods that we use in substitution method. There are some other methods as well for the substitution. This is not the end of substitution basically, okay. So, these are some formulas that we can modify, okay. Earlier the formula for x to the power n was 1 upon ax plus, the formula for x to the power n was x to the power n upon n plus 1. Now, we are modifying that x as ax plus b to the power n, and the formula for it will be okay. So, this is the formula divided by n plus 1. Similarly, the formula 1 upon x can be modified as 1 upon ax plus b, 1 upon a log of ax plus b. Integration of e to the power x can be modified as e to the power ax plus b, okay. So, if we have the formula for say integration of e to the power x dx, it was e to the power x plus c. Now, I have to integrate e to the power ax plus b dx. So, I will assume ax plus b equal to t, and we will use the substitution rule here, okay. So, we can modify the formula for sin x, we can modify the formula of cos x. So, integration of sin ax plus b will be minus 1 upon a cos x plus b, while the integration of cos is 1 upon a sin x plus b. So, these are the formulas which can be modified with the help of substitution method. Okay, now look at this few examples based on these substitutions method. I have to integrate tan of 3 minus x into sec of 3 minus x 3x minus 5. So, I will assume here 3x minus 5 as t. So, what I will go, let 3x minus 5 is t, and that will give us that dx equal 1 upon 3 dt. So, we use this substitution in the integration. Tan 3x minus 5 will be tan t, sec 3x minus 5 will be sec t, and dx will be 1 upon 3 dt. This 1 upon 3 is out, the integration of sec t into tan t with respect to x, and sorry, not with respect to x, it is with respect to t, and now we need to integrate it 1 upon 3, and the integration of sec into tan is sec x. So integration of sec t into tan t is sec t, and integrating constant. So sec t we know, whatever assumption we make for t is 3x minus 5, that I need to replace it again. So this is how we do the integration for ax plus b type of form. Now look at this another example for the substitution. Okay, in this case also we can assume, let this a square sin square x plus b square cos square x equal to t, and from here you will receive a square into 2 sin x cos x, the derivative of sin square x, while receive b square minus 2 cos x into sin x as the derivative of cos square x, and dx equal dt. Okay, now we can take 2 sin x cos x as common and we can convert them into sin 2x. So what we have is a square, or let's go for the next step, that will be cos, okay, we received sin 2x dx equal 1 upon a square minus b square dt. Okay, so when we will replace it in the integration, we get sin 2x dx is 1 upon a square minus b square dt, while the term in denominator was assumed as t. So I have to integrate 1 upon t, and the integration of 1 upon t is log t. So we have log of t plus c, and this t can be replaced again in terms of x. So it is log, t was assumed a square sin square x plus b square cos square x plus c. So this is how we do this integration. Okay, so all these are quite simple integrations that we can do. Okay, let's move to the problems. This is another situation we can deal for the integration. Okay, we need to assume this 2 plus sin 3x as t. Okay, and that will give us cos 3x with 3 dx equal dt. So from this substitution we can convert the integration into square root of t into 1 upon 3 dt. Okay, and this is simple, 1 upon 3 is out, t to the power 3 upon 2, 3 upon 2. So this answer is 2 upon 9, and my t is 2 plus sin 3x to the power 3 by 2 plus c. So this is the substitution, another problem. Okay. Now let's slowly move to little complex questions. Okay. Another problem based on the substitution method is square root of 10x sin x into cos x. Okay, we are not going to assume any term t. First we will do certain arithmetic with it. We try to convert this function or the integrand into a simpler form, then we will assume a function as t. So in this case what I do, I will multiply a root t in root 10x into numerator and denominator. So that is a change we are going to do. We have just multiplied a 10x, root 10x. So this is the integrand we have. Okay, and we are going to multiply with it 10x upon square root of 10x. So we have just multiplied and divided by root 10x. Okay, so in numerator we have root 10x into root 10x, that become 10x, and that 10x can be written as sine upon cos. So we have sine x upon cos x, that is the multiplication of root 10 into root 10. We have one more sine x cos x, that was already in denominator, and we have a root 10 x is there. Okay, so what is the sine cancel with the sine? These two cos can be taken back to the numerator, and what you will receive? We receive the integration of sec square x and the divided by root of 10x plus c. Okay, now we'll make the assumption, let my 10x is t, and from here I get my sec square x dx will be dt. So my integration will become sec square dx become dt. Oh sorry, we don't need to add plus c here. Okay, it is dx. Okay, so what I need to do, sec square x dx become dt and root 10x become root t, and now we can apply the formula t to the power half divided by half, okay, plus c. So we have the answer with us 2, and my t was assumed as 10x, 10x, sorry. This is t we have assumed, and the power is 1 by 2. Okay, so this is how we do these simple integrations. Sometimes we can directly take the term as t, sometimes we need to do little arithmetic, we need to convert the problem into a simpler form, then we can proceed for the integration or substitutions method. Okay, now if we look at some more problems. Okay, this is another example. Okay, again we need to do certain manipulations in the problem, and before going to that manipulations, okay, हम assume करेंगे let 1 plus x cube equal to t. So from here what we have, 3x square dx will be dt. Okay, so the manipulations we'll do with the function integrand is x5 will be written as x cube into x square. That is a simple manipulations we are doing. And now my x cube will be converted as t minus 1, that is with the help of substitution. X square dx can be converted into 1 upon 3 dt, and it is divided by square root of t, that is t to the power half. Okay, now we can simplify this integration as t upon t to the power half, so that is t to the power half minus 1 upon t to the power half, that is t to the power minus half dt. Now we'll do the integration. So t to the power half will be t to the power 3 by 2 upon 3 by 2, and the next can be t to the power half upon half plus integrating constant, and now we can replace the t as 1 plus x cube to get the final solution. Okay, so the rest part of this problem is quite easy, that anybody can do. Okay, now little the problems that we face in Iit-Jee Advanced. Okay, the problem we are taking based on this indefinite integrations. The first one is the integration of x square minus 1 upon square root of x cube into square root of 2x4 minus 2x square plus 1. Okay, so we need to do little arithmetic with it. Okay, so what we are going to do here, this x square minus 1 upon 5 will be divided by x to the power 5. Okay, and now the same we are doing in the denominator. So denominator will give us 2 x4 minus 2x square plus 1 upon x4. Okay, what we'll do here, we'll divide the numerator and denominator both with x to the power 5. So when we are dividing the numerator with x to the power 5, it is here, and when we are dividing the denominator with x to the power 5, x cube will be cancelled out and remaining x square will taken to the square root sign, and that become x to the power 4. On further step, it will be like 1 upon x cube minus 1 upon x to the power 5. That is the numerator we have received, while in the denominator we have received 1, we'll take this x to the power 4 separately below to the each term, okay, and we received 2x4 upon x4, which will give us 2, minus sign 2x square upon x4 will give us 2 upon x square, and the next term will be plus 1 upon x to the power 4. So after doing this much simplifications, I'll assume let this 2 minus 2 upon x square plus 1 upon x to the power 4 is t. This is the term that we assume as t. Okay, and from here, if we do the differentiation, we'll receive 4 upon x cube minus 4 upon x5 dx equal dt. So by using these two substitution, okay, this numerator can be converted into dt and denominator can be converted into t. Okay, so what is the next step we have received? 1 upon x cube minus 1 upon x5, we can take 4 out of from here and that can be transferred to the right side. We received 1 upon x cube minus 1 upon x5 dx is 1 upon 4 dt, and it is divided by square root of t dt. Okay, so now we have received a simple form of the integration of t to the power minus 1 by 2 with respect to t, and that integration can anybody do. Okay, this integration can be done. Okay, this integration can be done. The 1 upon 4 and t to the power 1 by 2 upon Okay, so for this example, we need to substitute sec x plus tan x equal to t. Okay, and from here we received sec x tan x as derivative, for tan x sec square x for derivative, and we have dx equal dt. So from here we can take sec x out and we received tan x plus sec x dx equal dt. Okay, so now in this case this tan x and sec x I am taking to the right side, and we received sec x equal, so sec x into dx equal dt upon tan x plus sec x, and this sec x plus tan x we have just assumed it is as t. So what we can do, we can write this sec x dx as dt upon t. This is the substitution we are going to use. In this case also, what we are going to do, from this sec x plus tan x equal to 2, if we do little trigonometry here, we received sec x minus tan x as sec x tan x equal to 1 upon t, and if we add these two terms, we received sec x equal 1 upon 2 of t plus 1 upon t. Okay, so now we are going to use the substitution method for the problem. Okay, so this given integration, the given function or the integration, it is going to write this sec square x, I am going to write sec x into again sec x dx, and in denominator we have sec x plus 10x as t, so I am going to write it as t to the power 9 upon 2. Okay. Now furthermore, 1 sec x dx will be written with this rule. Sec x dx will be dt upon t, and the second sec x I am going to replace with this function. Okay. So what we received here, okay, so from this term we received integration of, so the sec x dx will be dt upon t. We have one more t to the power 9 by 2, and by using that the rule, 1 sec can be written as 2 t plus 1 upon t. So this is the conversion by using the substitution. Okay, now we can do simple arithmetic here, and this will give us 2 is out. Okay, this t and this t to the power 9 by 2, that can be simplified as t to the power minus 9 by 2 plus t to the power this 1 upon t, t to the power 9 by 2, and this t will be t to the power minus 11 by 2. Not 11 by 2, it is 13 by 2, sorry. It is t to the power minus 13 by 2 and dt. So now we can do it in integration. So t to the power 9 by 2 in the integration will be minus 7 by 2 upon 7 by 2. For the next term, it will be t to the power minus 11 by 2 upon minus 11 by 2 plus integrating constant. Okay, and now it is minus 4 upon 7 and t to the power minus 7 by 2. What we have assumed a t? The t was assumed sec x plus 10x, that was initially assumed as t. So we have minus 4 upon 7 as the first term, and the power is minus 7 upon 2, while for the second term we will receive minus 4 upon 11, and t was sec x plus 10x, the power will be minus 11 upon 2 and plus integrating constant. So that is how we complete this problem. Now let's move to one more example, one more problem. Integration of cos cube x plus cos to the power 5x upon sin square x plus sin 4x dx. Okay, in any situation we need to choose the substitution wisely. So what we are choosing it here, let sin x equal t. So it will give us cos x dx equal dt. Okay, so what I am going to do with the integrand, we will take one cos out, and inside the bracket we receive cos square x plus cos to the power 4x divided by sin square x plus sin 4x and dx. Okay, so this cos x dx will be my dt. Now the cos square x, from this sin square x, my cos square x will be 1 minus sin square x, so it will be 1 minus t square. This is the cos square is replaced in terms of t, while the cos 4x can be considered as cos square x whole square, so it is like that 1 minus t square whole square. So this is the numerator we have, while in the denominator we have sin sin square x and sin to the power 4x. So sin square x is t square, while the sin 4x is t to the power 4x. Okay, we'll do little more simplifications. We have 1 minus t square plus 1 minus t square to the power 2 can be expanded as 1 minus 2t square plus t4 divided by, in denominator we have t square is common, 1 plus t square is there. So this is how we can do the simplifications. Now for the next step, we can simplify the numerator little bit and we'll receive 1 minus 1 is constant, another 1 is there, so we have 2 as constant, and then t square minus 2t square is minus 3t square, and then we have plus t to the power 4, and it is divided by t square 1 plus t square dt. Okay, so now we need to do some division process here. Okay, we need to simplify the given term. Okay, with the term we have in numerator, that we need to divide this t square 1 minus t square as the division process, and we'll reach to a simplification term. Okay, let me just remove it. Okay, so this is the term we have, the integration of 2 minus 3t square plus t4 upon t square 1 plus t square dt. Okay, so that is the, yeah. Okay, so we need to integrate it from here. Now it's in simple algebraic functions, the polynomial functions we have. Okay, so either we can look at the partial fractions, okay, to break this term into the partial fraction, and then we can proceed for the simple integration. So for the partial fraction, what we can assume, we can go for the partial fraction of this term, 2 minus 3t square plus t4 upon t square 1 plus t square, and that can be partially fractioned as a upon 1 plus t square plus b upon, just a sec, yeah, it will be as a upon t plus b upon t square plus ct plus d upon 1 plus t square. So this is how we can do the partial fractions here. So use the partial fraction technique, okay, then we can proceed for the simple form of the integration. Okay, so what we do in this case, for the partial fraction technique, it will be like 2 minus 3t square plus t4, and on the right side we have a into t square, t into 1 plus t square. Then with b we have only 1 plus t square, and with c t plus d we have t square. Okay, and somehow we can need to find a, we need to find b, and we need to find c, then we need to find d by using the partial fraction technique. And after getting these a, b, c and d, we can convert this function into the partial fraction, and then we can apply the formulas. The which we need is 1 upon t, we need the formula for the integration of 1 upon t square, and we need the formulas of the 1 upon t square as well. Okay, so by using those formulas we can integrate this function. Now it's a simple job, so that anybody can complete it. Okay, so that's all for today. This is all we supposed to complete. Okay. Yeah. So that's all. Okay, we can wind up.